Okay, we are now approaching the middle of chapter 10. So, multiplying and simplifying radicals. The square root sign. It doesn't have to be a square root, it could be a cube root, whatever. But I want to multiply and simplify the radicals. We're going to talk about this a couple different ways. First of all, you have to know the product rule. The product rule says that if I have that same power that you're using with the radicals, if you're having the same power, you can multiply those two things that are underneath the radical sign, the radicand. You can multiply those two things. Okay? This is the product rule. Not so much that you must know like exactly what the product rule says, but you have to know the meaning of what the product rule says. So, this is a square root. Remember, if you just have the radical sign and there is nothing there, that's a 2. It's kind of like a given that that's a 2 because we call that a square root, obviously, for 2. So take a look at this. Now, I can't simplify this because the square root of 3 I cannot simplify. So what I do is I multiply what's underneath, and I have the square root of 3 times 7, or the square root of 21. Do you have to put that extra step in there? Absolutely not. You could just go say 3 times 7 is 21. Then I have to take a look to say, is there a way that I can reduce this? Well, the answer is no. Remember, you're looking for perfect squares. If you're having a square root, you're looking for perfect squares. If you have a cube root, you're looking for perfect cubes, and so forth. Now take a look at this. Well, this automatically says, ooh, this looks kind of ugly. But they both have the square root that tells me that I can multiply what's underneath. So I have this, x minus 7, x plus 7. Now if we can remember our foiling technique, which says this, the square root of x squared, well this is plus 7x minus 7x, cancels. And then minus 49. Well, that's my answer. Again, if you look at the FOIL, x squared plus 7x minus 7x minus 49. And if you take a look at that, obviously these two middle things, those two middle terms, they cancel each other out. Can I split these up? No, I can't say, well, what's the square root of x squared? No, if you have a plus or a minus in here, you can't split them up. They're a group. Sometimes I like to put a parentheses around them just to say, don't split those things up. Okay? Now take a look at this. Again, cube root, as long as they are the same, square, cube, fourth root, fifth root, doesn't matter. As long as they are both the same, you can multiply what's underneath those. So I have the cube root of 7 times 9, or the cube root of 63. Nothing I can do with that. Okay? So, again, multiplying seems kind of easy. That's us dipping our toe into the water. Okay. What if I got the 8th root? 8th root here, 8th root here. You have the same and they're multiplied together. That means that I can multiply what's underneath those things. So I have this. The 8th root of 10x times 8x to the 4th. The 8th root of, multiply the two numbers, I have 80. Add exponents when you see the two variables that are apart. You add exponents. Remember, if there's no exponent there, it's a 1, x to the 5th. Not bad, everybody's happy. We're still going strong. Okay? Simplifying by factoring, this is now where we start to actually get a little bit more complex. Write the radicand as a product of factors. So in other words, underneath that radical sign, I'm going to write that thing out as a product. Two things multiply together. Use the product rule, and then I'm going to find the nth root. Now you're saying to yourself, okay, I don't get all this, but you will see exactly when I start to do an example how we do this, how we use this product rule, and how we find the nth root. You will see that. Okay. So if I take a look, I have two examples here. This is the square root of 75. Now I can do a factor tree, and what I'm looking for is the largest perfect square. That's what I'm looking for. So I have this. If I do a factor tree of this is 25 times 3. That's a 5. It's 25 times 3. Well, if I do this, remember how I rewrite it as a product of its factors. So I'm going to rewrite it as 25 times 3. Now my product rule can go one way and then the other. I can split these things apart. The square root of 25 times the square root of 3. As long as they are both the same, squared, the square root, now I could split them apart. The square root of 25 is 5, and there's nothing I can do with the 3. Okay, so that's not bad. Again, just kind of breaking it apart. You can do the factor tree, but you're looking for, now this was the larger perfect square, so now look at this example. Now I got a cube. Well, I got to look for the largest perfect cube of 54. Well, when I look at 54, I'm thinking of probably something that is going to be of 2. I'm going to look at something that's going to be 2. So I'm going to look at this. I'm going to factor tree 54. And when I said that, you're looking for a 2 to take out because this is an even, so I know I can pull that out. Well, look at this. This is 2 times 27. 27 is a perfect cube. That's perfect. So now I have this, the cube root, and I'm just going to flip the order. 27 times 2. That's great. So now the cube root of 27 times the cube root of 2. That's my product rule in reverse. The cube root of 27, what times what times what gives me 27? Well, it's 3. The 3 cube root of 2. Now this basically is saying 3 times that. This is saying 5 times that, but you don't put that in there. Okay? Let's take a look at this. The 5th root of 64. Well, I'm going to start, I know I can break it down by a 2 again. And by the way, these are 2 separate examples. So 64, well, I know that this is 2 times, what is that, 32? This is 2 times, what is that, 16? This is 2 times, what is this, 8? 2 times 4, and 2 times 2. Now look at the 5th root. 1, 2, 3, 4, 5. 5. If I do this, if I multiply these things all out, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So the 5th root of 32 times 2, this is what's left over. Again, I'm making this the product of its factors. Well, now I can do the 5th root of 32 times the 5th root of 2. Well, we just said the 5th root of 32 was 2. Times the 5th root of 2. Now, is it easy? No, but again, you could do the factor tree. And again, if you got 5 of them, 5th root, if you got 5 of them, it's that number. It's that number. Okay, let's look at this. I'm going to rearrange this a little bit. This is the square root of, I'm going to do 500 times y squared times x. The only reason I switch that around, I can't take the square root of x. It's just the square root of x. So it kind of looks like this. Well, I can do this, and remember from a previous rule, it says that this is the absolute value of y. If you have something that's squared, a square root, it's the absolute value. If this is even square root, it's the absolute value. And this is square root of x. There's nothing I can do with the square root of x. It stays the square root of x. Well, let's look at this. What is the largest perfect square that goes into that? Well, probably 100. 100 times 5. The square root of 100 times the square root of 5. Well, the square root of 100 is 10. Now, I'm going to rearrange this because I've got this absolute value of y and the square root of x. I can do the product rule. I can smash them back together to simplify it. So I have the absolute value of y and the square root of times those two together, 5x. Now this may look daunting. It's not. It's not. Just kind of break things apart, work on them individually. Just remember the rules. Again, if you have an even with this square root, it's going to be an absolute value. Okay. Ooh. Remember how you'll never lose factoring? You'll never lose factoring. I got a GCF. That's the first rule that you do in doing factoring. You always look for the GCF. And I'm left with x squared plus 2x plus 1. So now, I can factor this. This is x plus 1, x plus 1. Well, what's another way to say that? Well, this is 2x plus 1 squared. I can split these apart. Again, the product rule. The square root of 2 and the square root of x plus 1 squared. Well, this isn't bad. Well, this doesn't change. But look, it's kind of like the square root and this 2 kind of cross each other out, and you're left with x plus 1. And then bring that square root of 2 along. You don't lose factoring. Sorry. Remember with factoring, look to see if there's a GCF. Look to see if you've got a factoring pattern. Again, this is what we do. See if you can simplify that. Okay. Simplifying to even powers. Now this is going to be, now you're going to say, okay, I don't quite understand this, but this isn't bad. Odd, odd, odd. It's a square root. Well, that's even. But these are all odd. I can't really do it. So this is what I'm going to do. I'm almost going to subtract one of these. So I'm going to say that this is x to the 4th times x to the 1st. Y to the 12th times y to the 1st. Z to the 6th times z to the 1st. Okay? Why I do this is because now, if I take a square root of x to the 4th, it's like splitting that thing in half. If I do this, if I do the square root of x to the 4th, this is like saying that this is x squared. It's like splits it in half. The square root of that thing. So I have this as my first term. Well, what's my second term? Split it in half. Well, this is now y to the 6th, and you're left with the square root of y. What about this? Split it in half. Z to the 3rd, square root of z. Well, now look at what all I got right there. I just got to combine it. My final answer is x squared, y to the 6th, z cubed, the square root of, product rule says take all those along, x, y, z. If you have a square root and odd exponents in there, just take one away from them, rewrite it, because you know that you can take the square root of something that's even. Ooh, I got a cube root. Now this thing is going to get a little more difficult because now I'm going to split this up. The cube root of 32, cube root of x to the 8th, and the cube root of y to the 16th. All right. So now, here's what I'm going to take a look at. The first thing I'm going to do is the cube root of 32. Remember, I can factor tree it. Well, it's 2 times 16 and 2 times 8 and 2 times 4 and 2 times 2. Look at this. 1, 2, 3. So this is, if I multiply these things, 2 times 2 is 4, 4 times 2 is 8. So this is a cube root of 8 times whatever's left over, which is 4. Well, the cube root of 8, we just said is 2. And I've got what's left over, the cube root of 4. Okay, that's just my number. Okay, now, if I take a look at the next thing, say with this, I have to see how I can get this cube root, and it's got to divide evenly into this exponent. So I'm going to take 2 away from it. So I have this. The cube root of x to the 6th times x squared. Why do I do that? Is because now if I take the cube root of x to the 6th, splits it in half, I get, not that, kid, erase that, I get x to the 3rd, and what's left over is x squared. Sorry, this is cube root, just so you know. And now this, I gotta look for something that 3 divides in evenly to. Well, look at this. If I take 1 away, it's 15. So I actually have the cube root of y to the 15, y to the 1st. Well, look at this. Just divide it by 3. So I have this. By the way, this was 2. Why did you catch me on that? Another error. Why did you catch me on this one? Y to the 5th, cube root of y. Oh, now that looks, I gotta try to combine all these things. I gotta try to combine all these things. So I have this, 2 x squared, y to the 5th, and what's left over with this cube root is 4 x squared y. Okay. Now again, you just divide 6 by 3, divide 15 by 3. I said cut it in half, but that was when I was doing the 2. I apologize. You don't do that, you divide it. Okay? Multiplying radicals and then simplifying. All this says is, hey, take a look at this. Well, I can't do the square root of 15, I can't do the square root of 3. But what if I multiply them together? What if I do this? 15 times 3, which is the square root of 45. Well, is there a large perfect square in there? Well, let's take a look. If I factor tree this is 5 times 9. Well, 9 is a perfect square. Look at this. I've got the square root of 9 times 5. Well, the square root of 9 is 3, and I'm left with the square root of 5. So you can multiply those radicals together and then simplify. Okay? Still kind of using the product rule. Now take a look at this. I've got a number on the outside and a cube root. So I can do this, multiply the 2 numbers on the outside, and I get the cube root of 6 times 4, which is 24. Well, let's see what 24 is. Now I can factor tree this, 24, which is 2 times 12, 2 times 6, 2 times 3. And I'm looking for cubes. I'm looking for groups of 3. Well, look at this. 1, 2, 3. Well, this is 35. The cube root of 2 cubed, or 2, 4, 6, 8, times 3. That's what's left over. So I have this. 35. Well, what happens when those 2 things, again, if I am multiplying these things, I can bring out a 2. Because this is the cube root of 8 times the cube root of 3. The cube root of 8 is 2 times the cube root of 3. Well, now I can just multiply the 2 and the 35. Okay? So, a lot going on here. We've got many different things, but we'll talk about this when we get back on class, because again, the whole chapter is all about radicals and radicands, radicand, which is underneath the radical sign. Have a good one.